Hello everyone, welcome to our group. We today will like to explain about our group assignment. These are our group members. As we all know that DC motor is the motor which converts the electrical energy to mechanical energy. Because of this energy, we can use this motor in number of applications. I would like to explain the operation and construction of commercial DC motor to provide a better understanding about our project. Firstly, we will start with the simplest DC motor possible. It looks like this. The stator provides a constant magnetic field and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC power source through a pair of commutator rings. When the current flows through the coil, an electromagnetic force is induced on it according to the Lorentz law. Hence, the coil starts to rotate. We can notice that as the coil rotates, the commutator rings connected with the power source of opposite polarity. As the result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity always flow towards. This ensures that the torque action is also in the same direction throughout motion, so the coil will continue rotating. But if we observe the torque action on the coil closely, we will notice that when the coil is perpendicular to magnetic flux, the torque action nears zero. As a result, there will be irregular motion of the rotor. Simply to overcome this problem, we add more loop to the rotor with a separate commutator pair for it. In this arrangement, when the first loop is in vertical position, the second loop will be connected to the power source. So, the motor force is always present in system. Moreover, the more loops, the smoother it will be for the motor rotation. In a particular motor, the armature loops are fitted inside slots with highly permeable steel layers. This will enhance magnetic flux interaction. Spring-loaded commutator brushes help to maintain contact with power source. A permanent magnetic stator pole is used only for very small DC motors. Most often, an electromagnetic is used. The field coil of the electromagnetic is powered from the same DC source. The field coils can be connected to the rotor windings in two different ways, parallel or series. The result is two different kinds of DC motor constructions. As we can see, a shunt and a series motor. The series wound motor has good starting torque, but speed drops drastically with the load. The shunt motor has a low starting torque, but it is able to run almost at a constant speed, irrespective of the load acting on the motor, as shown on the video. Moving on, unlike the other electrical machines, DC motor exhibits a unique characteristics, back EMF. A rotating loop in a magnetic field will produce an EMF according to the principle of electric induction. The case of the rotating armature loop is also the same. An internal EMF will be induced that opposes to the applied input voltage. That EMF reduces armature current by a large amount. Back EMF is proportional to the speed of rotor. As the starting of the motor, back EMF is too low, thus the armature current is too high, to a burnout of the rotor. Proper starting mechanism that controls the applied input voltage is necessary in large DC motors. one of the interesting variation of the DC motor is a universal motor.
This video is about DC motor fan. First, put the glue in the middle board to stick the stand. Next, we are using the wire to connect to the DC motor. Put the glue at DC motor to stick at the top of stand. Next, connect the wire at the switch. Put the glue beside the stand for easy to switch the fan. At the other side, we put the glue for the 9V battery. Connect the wire at the battery. Lastly, connect the fan to DC motor. And it works, so we assume our project is success. Thanks for watching.